Welcome to the overview of GS1's Event-Based Traceability. I'm Craig Allen Repick, Senior Manager of EPC Global Technology at GS1 Global Office, joined by Dr. Mark Harrison, Director of the Auto ID Lab at Cambridge University. Electronic Product Code Information Services, or EPCIS, is an open GS1 standard which defines data interfaces and a data format for the capture and query of physical event data in the supply chain, both within and across enterprises. EPCIS is data carrier neutral. In other words, it does not require RFID and works fine with barcoded identification. Initially designed to support only serialized identification, the latest version of the standard, published in May 2014, includes support for lot and batch-based traceability for applications where serialization is not currently feasible. Lot-batch level granularity is particularly relevant for medical devices, although it should be noted that serial-level identification provides the highest fidelity in traceability and the greatest ability to support a wide range of checks on its integrity. EPCIS is the result of over 10 years of work by the global GS1 community, including manufacturers, distributors, retailers, and technology solution providers working together to define a common, global, multi-sector approach to exchanging supply chain event data. EPCIS supplements rather than supplants traditional EDI/ECOM transaction messaging and is positioned as an enabling tool for supply chain transparency and traceability. EPCIS events comprise four main dimensions. The what dimension indicates the objects that are the subject of the event, such as individual trade items identified by GTIN and unique serial number, product groupings identified by a GTIN and lot or batch number, or logistics units identified by serial shipping container code. The when dimension is a timestamp of the event, indicating the exact date, time, and time zone at which it occurred. The where dimension indicates the physical location of the event, as well as the object's whereabouts subsequent to the event. Both of these locations are uniquely identified by Serialized Global Location Number, or SGLN. Finally, the why dimension indicates the business process step associated with this event, as well as the object's subsequent disposition or status, and any applicable source and destination endpoints in the context of a transfer of ownership or custody. EPCIS is a well-established global open standard for expressing, sharing, and requesting event data and is the foundation of the modern GS1 approach to event-based traceability. This includes a number of distinct aspects, such as tracking, tracing, and recall, as well as chain of custody and chain of ownership. As such, event-based traceability and its foundation EPCIS can help the safety and security of supply chains by detecting the insertion and distribution of counterfeit products. GS1's Event-Based Traceability Workgroup is engaged in the development of a new suite of GS1 standards under the Event-Based Traceability umbrella. Event-based traceability comprises the capture, sharing, and analysis of EPCIS event data in order to determine the provenance history of a specific physical object with a specific focus on checking the integrity of the chain of custody or chain of ownership. This technique can be leveraged to improve the safety and security of supply chains by detecting the insertion and distribution of counterfeit products. The Event-Based Traceability Suite includes standard specifications for three components. Checking services automatically collect upstream event data and analyze it for any gaps and inconsistencies. A security framework ensures that event data can be shared securely on a need-to-know basis, typically within the supply chain path, so that it does not leak into the hands of competitors and is not misused or analyzed for other purposes. Choreography models, in turn, explain how to use EPCIS repositories in combination with checking services. The choreography models are being defined for centralized, semi-centralized, and distributed approaches to the storage and retrieval of event data. Note that the security framework is being developed for each of these choreography models and will apply equally to each of them. It's important to understand that none of these individual models is inherently more secure than another. In each model, the data that is contributed to the repository will only be shared with other parties if they are entitled to see that data. Typically, this requires being a downstream party on the same individual chain of custody or chain of ownership of the product. Note also that a centralized model does not confer any special privileged access to the data to the host of the repository. In the same way, the data that is contributed to a semi-centralized repository by parties downstream of the brand owner or manufacturer is typically not visible to the brand owner or manufacturer that nominated the semi-centralized EPCIS repository to be used for event data about their products. This presentation focuses on the semi-centralized model in the context of implementation discussions pertaining to the Brazilian market.
In the next 3 slides, we will look at the semi-centralized model in more detail. The first stage is setup, where the brand owner, company A in this diagram, creates an object name service ONS record to link the GTIN of their product to the address of the EPCIS repository that they wish to nominate for storage of event data about their products. Anyone can query ONS with the GTIN of a product to discover the address of the nominated semi-centralized EPCIS repository to use for that product. The next stage is capture, where each organization captures EPCIS event data about the product instances they handle and contribute this data via the EPCIS capture interface of the appropriate semi-centralized EPCIS repository. The third stage is query. Any party can query ONS with a GTIN to find the address of the semi-centralized EPCIS repository. They can then submit a standardized EPCIS query to the EPCIS query interface. If their security credentials are valid, and if they have a right to receive the event data, they can then retrieve a copy of EPCIS event data from the repository that matches their query. Typically, access control policies will permit a party further downstream on the same chain of custody to obtain event data contributed previously by parties further upstream. Checking services can be used not only for checking event data, but also for forwarding it to the appropriate semi-centralized repository. In this diagram, we see distributor B and provider C sending EPCIS event data to the capture interface of their chosen checking service. Each checking service analyzes the data to determine the GTIN of the products, then consults ONS to find the appropriate repository, and then relays the EPCIS event data to the appropriate nominated EPCIS repository for that product. Here we see checking services performing their main role of gathering and checking upstream event data, running a number of tests on the data to check for any gaps and inconsistencies, and finally delivering summary reports for any incoming products so that the distributor and provider can be informed in advance of the goods arriving about whether there are any problems in the traceability data for specific objects, which might lead them to refuse receipt or to quarantine them for further investigation. The idea of checking services is that any supply chain party can outsource the burden of gathering and checking of upstream event data to a trusted, accredited third-party solution provider of checking services. The supply chain party configures their chosen checking service with a number of details, including the product GTINs they typically handle, a list of GLNs of their regular suppliers, a list of tests and configuration parameters for those tests, as well as listener addresses where the summary reports and alerts should be sent. A checking service begins gathering event data, usually triggered by the shipping event of an incoming shipment. Upstream event data can be gathered automatically and checked using a number of tests. The result is a summary report which indicates for each EPC whether each test passed, failed, or generated a warning. A checking service summary report is sent to the supply chain party and provides actionable information that indicates which EPCs passed all tests as well as lists of EPCs involved in tests that generated warning messages or failure messages. This information enables distributors, wholesalers, and providers to make appropriate decisions about whether to accept shipments and put them away into inventory, or whether they need to quarantine particular objects that have problematic traceability data. The Event-Based Traceability Workgroup is also developing a security framework that supports fine-grained access control to allow EPCIS event data to be shared on a need-to-know basis within the actual specific chain of custody or chain of ownership, eliminating the risk that this commercially sensitive data falls into the hands of competitors outside of the actual chain of custody.
The security framework comprises 4 distinct aspects. Authentication provides for checking the identity and attributes of a user that connects to the checking services and in turn to the EPCIS repositories within the event-based traceability infrastructure. Authorization prevents unauthorized access to event-based traceability data, including the insertion of spurious event data, as well as mining or abuse by competitors seeking business intelligence. Access control defines and evaluates the rules that determine whether and to what extent event data will be shared with a particular party. The audit trail keeps track of the chronology and parties involved in all read-write operations with data. A non-standard proprietary approach to event-based traceability would substantially hamper the interoperability of any deployed solutions. The resulting inability to understand another party's data and the inability to share such data would cripple attempts to satisfy regulatory requirements for information pertaining to the chain of custody and chain of ownership in an efficient and minimally disruptive manner. Alignment with a well-designed open standard promotes interoperability across multiple solution providers and in turn increases choice while decreasing costs for all supply chain stakeholders. EPCIS 1.0 was published in 2007 and is already supported by major commercial technology solution providers including IBM, SAP, NEC, Microsoft, Axway, Samsung, T-Systems, LG, NTT and Hitachi, as well as a free open source implementation from FastTrack. EPCIS 1.1 was published in May 2014 with implementations already planned by major solution providers and certification scheduled to begin in early 2015. A list of certified EPCIS providers is publicly accessible at GS1's website.
We encourage you to get involved and also to encourage your solution providers to participate. You can join the Event-Based Traceability Workgroup in the GS1 Community Room. There, you can access the educational material, our strawman document for event-based traceability, as well as the informative document for the security framework. By opting into the workgroup, you can also access and influence the drafts of the event-based traceability standards as they are being developed. For further information about event-based traceability, please contact John Ryu or Janice Kite, or find us at gs1.org/healthcare. Thank you for listening.